Okay, so let's begin with a video on probability and odds. Our objective here is to be able to find the probability of an event and also to find the odds for the success and failure of an event. Our first example is an entertainment one. Each year about 50,000 people audition to become contestants on a show that seeks to find the best singer and award him or her a recording contract. Only 12 are chosen to be finalists on the show. What is the probability of being selected as a finalist? Well, remember that probability is the number of successful outcomes we want compared to the total number of outcomes. Okay? So we can say that the probability of being one of the 12 chosen would be 12 compared to the 50,000 total that are signing up for the competition. So that reduces then to 3 over 12,500. Our next example is one of my favorite topics, cookies and cookie jars. For this one we say a cookie jar contains 9 chocolate chip, 5 oatmeal, and 6 sugar cookies. What is the probability that a cookie selected at random will be a sugar cookie? Okay, so for our first one, for A, we would say that the probability of selecting a sugar cookie would be 6 out of the total 20 cookies, or 3 in 10. Now for the second part, what is the probability that a cookie selected at random will not be chocolate chip? So we say for B, the probability that it's not chocolate chip, we'd say, all right, well, there's 11 cookies in here that are not chocolate chip. There's 5 oatmeal and 6 sugar. So that makes a total of 11 out of the 20 cookies. So it's 11 out of 20 that would not be chocolate chip. Okay, our next example gets a little bit more complex, and we'll have to revisit the concept of combinations. So this one says a class of 15 children is made up of 6 girls and 9 boys. If all their names are placed in a hat and then 4 names are selected from the hat at random, what is the probability that the names chosen will be girls? So for this one, we're trying to choose find the probability that we're choosing 4 girls. Okay? So what we're going to do is we're going to look at all the combinations of 4 girls being drawn up versus all the ways 4 students in general from this class can be combined. Okay? So again, we have the combinations of, from that 6 girls, that 4 of them can be drawn up, as opposed to the combinations of those 15 students altogether, that 4 of them can be drawn up. So now you need to go back to your combinations formula, and this will come out to 6 factorial over 6 minus 4 factorial times 4 factorial all over, so that's the combination of 6, 4 for n and r, and then on the bottom we're going to have 15 factorial over 15 minus 4 factorial times 4 factorial. Alright, so when I simplify all that out, we get 1 in 91. So again, this is all the combinations that I can pick 4 girls from the 6 versus picking 4 students of the total 15. Okay? Okay, our next example adds an interesting twist onto this combinations thought process. An automobile manufacturer determines that for every 20 cars it produces of a particular model, 2 will have a defective oil tank. If a car dealership has 20 cars of this model on its lot and sells 4 of them in 1 week, what is the probability that at least one of the cars sold has a defective oil tank? Alright, so for this one, it's actually easier to find the probability of selling one without a defective oil tank and subtract that from 1 to find the possibility of having a defective oil tank sold. And that's because we can't take 4 out of a group of 2 defective ones. We can take groups of 4 out of the 20 cars, or out of, rather, the 18 that are not defective. But we can't take groups of 4 out of the 2 that are defective. That gets really weird. So what we're going to do is state this. The probability for selling at least 1 defective oil tank, it will be equal to 1 minus the probability of selling no defective oil tanks. Okay? So what that gives me then is 1 minus the number of possible combinations for not having a defective oil tank. So we're saying that 18 of the cars on the lot do not have a defective oil tank, and we're choosing groups of 4 from them out of the total number of cars is 20, which is, and we're choosing groups of 4. Okay, so doing the number crunching here, that gives me 1 minus 30,060 out of 4,845 using the combinations formula we used in the previous problems. And so as a percentage wise, instead of a fraction, we're going to use a decimal and then turn that into a percentage. Okay, so as a decimal first, this comes out to about 0.368, which is about 37% probability. So it's that you will sell at least 1 defective. The other flip side of that is you could look at it as a 63% probability of not selling a defective oil tank that week. Okay. Now just to clarify how this problem was set up again, another way to look at that is that if I took the probability of selling at least 1 defective and added to that the probability of selling no defectives, the combination of the 2 of them would give me 100% of everything that's sold, or 1 for my probability. Okay, so if I combine those 2, each of those parts of the whole, if you want to look at probability as parts of the whole, they would come out to 1. So then 1 minus the probability of no defective would give me the probability of at least 1 defective. Okay, so for one more example, we're going to do a simple probability problem and then switch it over to look at odds as opposed to probability. Okay, so for this one, a game at a town fair has children using a fishing rod with a magnet at the end of the fishing line. I remember playing those as a kid. And they use that magnet to catch plastic fish floating in a tank of water. Underneath each fish is either the letter S or L. If a child catches a fish with the letter S, she may choose a small prize. If a child catches a fish with the letter L, he may choose a large prize. There are 40 fish with the letter S and 10 fish with the letter L. All right, so first thing I want to say is, what is the probability that a child will catch the fish with the letter L? Because we all want the big one, okay? So the probability of catching a large fish, let's denote that as P of L. Well, looking at that, there are 10 fish of the 50 that will have the letter L on it. So the probability is 10 out of 50, or simplified 1 out of 5. Okay. Now let's switch that over to the odds. Okay. Now, if I want to look at the odds of catching a large fish, okay, so the odds, now that's going to be the comparison of the number of desired events to the number of not desired. Okay, so in this case, there are 10 fish that I want to catch, 10 of the large ones, compared to the 40 that I do not want, because those are the small prizes. So this gives me 1 versus 4 for the odds. Okay, so I hope that helps you with doing some of your problems with probability and odds. Before we stop, let's get just a tad bit more involved. Okay, so for this last example, we're not only going to use combinations, we are going to use the basic counting principle, and then we're going to do probability and odds of an event. Okay? So this is, as a fundraiser, a school is holding a raffle. Out of the general pool of participants, 25 are selected to enter the grand prize drawing. 4 grand prizes are to be given to 4 individuals. If there are 15 men and 10 women selected for the grand prize drawing, and the names are drawn at random, what are the odds that 1 will be male and 3 will be female? Okay. So, taking a look at this, let's first find out the number of ways that we could have 1 male and 3 females. So what we'll do for that is we'll use the basic counting principle with combinations. So the number of combinations for choosing 1 man, okay, so that'd be, we have 15 men, and how many ways can we draw 1 out of that? That would be represented by that. And then for the women, we would have the combinations from the 10 women, choosing 3 of them. Now those 2 values, using the basic counting principle, I would multiply together. Okay, oops, sorry, I had a little technical glitch there. I'd multiply those together using the basic counting principle. And that comes out to a total of 1,800 possible groupings. Okay, so there's 1,800 possible groups of that for the 1 man and 3 women to be chosen. Okay, but now let's compare that to how many groups of 4 could be taken out of the general population. So how many groups of 4 out of the 25 total? So how many combinations can I get from 25 people chosen in groups of 4? Well, I crank that out, and that comes out to 12,650. That's a lot of combinations. So now, if I was just looking for probability, it would be 1,800 over 12,650. Okay? Now remember, these are the desired ones. Okay? These are desired outcomes. Combinations of the ways that can happen. So if I take the desired outcomes away from the total number, okay, so I'm going to do 12,650. That's the total number of ways we can get groups of 4 out of that 25. And I take away from that the 1,800. That leaves me then with 10,850 other possibilities that I don't want. So the odds here would be equal to 1,800 compared to 10,850. Okay? So that simplifies to 36 versus 217 that I don't. Okay? Which is close to 1 versus 6. Okay? There you go. I hope that helps quite a bit. Remember, the basics of this is probability compares the number of desired outcomes to the total number. Odds compares the number of desired to those you don't desire. And that sometimes we need to do find the total number of combinations, the way something can happen first off. And even when we have 2 events that we are putting together, we can use the basic counting principle to find the total number of possibilities, or combinations rather, as we did in this problem. Good luck and have fun.